and technology transfer are crucial for observing the growth of the development national. And to form the strategic partnership and can aid the national development program. The Indonesian Precast and Pre-Stressed Concrete Company Association, or AP3I, is the construction service supply chain organization that represent product technologies, innovation that have played an important role in supporting infrastructure projects, as well as building and housing construction in Indonesia. Today's event is truly important, especially for AP3I Association and its member. Hopefully, all the attendees, including delegates from institution and university, will be able to exchange thoughts and ideas in this event. We are all hoping that this activity would go smoothly, and we encourage you to take full advantage of this opportunity. We wish you an enjoy experience. And don't forget, cintailah produk Precast Indonesia. We grow, we green, we sustain. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Thanks, Ibu Dewi.
Thank you so much, Ibu Dila, for the inspiring message and also continued support. So now let us proceed with the presentation, the main agenda of our today's webinar. So we have in this session, moderator Bapak Dudung Maulana Tekstianti serves as General Secretary of AP3I. Pak Dudung graduated in Civil Engineering and Planning from Institut Teknologi 10 November, Surabaya, and he furthered his education in business management and quality internal auditing. His career spans leadership roles at PT Adikarya, advancing from project head to manager and director positions across various divisions, including construction, production, and international operations. Since 2016, Pak Dudung has been a concrete expert at PT Adi Perkasa Beton in Jakarta. So during this session, we have also 4 distinguished speakers, and I would like to introduce to you our speaker. Our first presenter is Mr. Harwin Sand, President Director of Earth Tech Group Ltd. Mr. Harwin is a licensed professional engineer specializing in mechanical stabilized earth retaining walls and innovative reinforced soil structures. With degrees in civil and structural engineering plus an MBA from Cornell University, he has developed patented MSE system used worldwide, including some of the largest infrastructure projects include the Sharkbite Heavy Data Bridge, built the mining traffic and recognized as the world's widest bridge. Also, the wood fiber LNG project featuring single MSE walls reaching 21 meters in height. Earth Tech Group has e-panel system, which is the first and only MSE retaining wall panel in the world made from recycled plastic, engineered for a design life up to 120 years. It significantly enhances recycling efficiency by accommodating mixed plastic streams and can be fully recycled at the end of its service life. So without further ado, I would like to invite Mr. Hartwig Sand to deliver the opening remarks. Sorry, to deliver the presentation. Over to you, Mr. Hartwig.
Thank you. And let me share my screen then. So good morning, everyone. So I'm happy to be here to introduce Earth Tech Solutions and its e-panel and e-wire systems, which could be used for project in front of water heavy especially for the seawall, giant seawall in Jakarta. So today, mainly we introduce the two systems under the company. Also, just to get some outstanding applications comparing to the other systems available in the market. And meanwhile, welcome the colleagues in the PRECAST sector to contact us for partnership to deliver the new technology and the products in the local market. So Tech, just an engineering company, focus on all different kinds of MSE retaining wall, a GRS, ABS system, and RSS system. So from engineering, full engineering qualification in Canada, and we could work closely together with the local companies to deliver the project, even though the partnership internally has no experience in retaining wall section. So we can do the product supply and the project management also. Retaining wall system all over the world right now, we could classify them into two categories. The first one is a steel, which means using steel as a soil reinforcement behind the panel. While we talk about a panel wall, actually all the panel was required by project spec, so they are all the same. But the supplier just work differently from the back of the panel. But steel so far has a advantage is a rigid system, but the disadvantage is especially in front of the de-iced water. So the corrosion is a kind of a big concern. Inside of the panel, currently we upgraded it into stainless steel currently, but behind it, it's too expensive to just upgrade it from coated to galvanized and then low carbon and then stainless steel. So other than the steel soil reinforcement, we also have HDPE geogrid using the geogrid to connect it behind. But this system has a disadvantage is the creep factor and the connection just between the two pieces has a gap, may allow the panel to rotate a little bit during the installation or after. So that's the two major systems. Meanwhile, usually you see this geogrid called the polyester geogrid, which was widely used in foundation reinforcement and for retaining walls without mechanical connection requirements. So it's very popular, but due to no mechanical connection, so it was used only for a certain area. But currently, we find the way to connect it to both the concrete panel and the e-wear basket. So we call it e-panel and e-wear system simply. So while you use this material, you know, in the market is 40% cheaper than the same strength of steel and HDPE. So the overall system saving will be over 20%. So next question is if it's strong enough to be used for retaining wall. With a two-lock block, we tested over 40 kilonewton per meter, and in the lab, we tested 96.8 for the 10XT, which is 68%, more than double of the required design strength. So other than that panel system, we also could just cast the panel using recycled plastic. So that's the test in the lab, and we got a successful result after. So with the system, we can use it for different kinds of finish from the front, actually they are all the same comparing to any system if you need. After we talk about the panel system, this one is the e-wear. So the e-wear means is a kind of L-shaped wear system using the machine to backfill it. With mechanical connection, we can build it straight. Usually in the market, you see the wear system is like this. So either do a short wall or do a permanent wall, but at 70 degrees or shallower, or temporary wall. So you couldn't use it for a high wall permanently straight, except you have a mechanical connection. And this one has a mechanical connection, rely on the bar to connect to the basket and hold it. And most of you may see those systems in the market. Also, they use a geogrid wrap around the filled bag. And after that, they just add the second facing as a two-stage. But remember, while you do that, you need lots of steel. The red line represents extensive steel between them. So when we talk about the e-wear system, comparing to the traditional way used in the market, we wrap it around the bar in the basket. And meanwhile, we use a very strong strut to hold it in place and go against the direction while you're pulling it. So while you're pulling two pieces separately, go with one piece, go underneath of your basket, you can use it for two-stage, which will make the two-stage system way easier, and the overall cost comparing to the competitive will be over 30%, even 35% cheaper. So if you rotate the basket another 90 degrees, you will see a very similar wrap around with a picture I just show you. But this one has two advantages. First one, you see on top, we have a bar, with the geogrid go inside and around it. So which means you get all the strings go at the same point to bend back. So it's optimized for the finish and then optimized for the strings. So use the system, we built the world's widest bridge. So this one is a 10.5 meter tall and 73.5 meter wide. And it is a heavy duty with 102 kPa. Usually you won't see that much, except in the mining zone. That's for the big mining trucks. And then along the Trans-Canada Highway, we built the true abutment bridge. That's 11.76 meter tall. And that's very, very tall for a true abutment, which means there's no piles underneath of the superstructure. So all the superstructure sit on top of the wall only. So here is a two-stage example where we design it. You see, we can keep multiple connection to the panel, and meanwhile the distance is flexible. We can adjust it, depends. We use it. So this is not the picture use this technology, but it's a very similar one I did. So 12 years ago. So other than the simple wall and the two-stage, we also have a very special situation. Usually the other systems couldn't be used. So for the limited space, such as in case you're working at in front of a mountain or a slope, you don't want to overcut it. So without enough room to run the geogrid. So in that case, we have this solution. You see, we can cast a concrete at the bottom and meanwhile connect the either basket or the panel on both sides from both ends to connect it. So there's no limit on the spacing. So we can design the concrete section based on its weight and size to balance the overturning and the sliding and solve the problem for some special situation. That's a unique requirement for this system. Meanwhile, you see this one at the bottom, we can straight up the slope on the big heavy inside of the trench so that we can add 2 more lanes without occupying more lands. So you may think, ask a question, see if it's strong enough to do it. You see this photo show you, we have a project in Ottawa, use this basket for a 240 kPa. So which for 15 times of the normal heavy traffic and allow the bridge replacement in 3 days. That means 77 hours for 8-lane bridge. We replaced it and get the traffic back. So another situation, especially good for the giant seawall, is for this one. Usually, while you do some structure along the ocean or some waterfront or soft ground area, it's very difficult, except you want to just using the pail drive into so that you can get a small area on top. Comparing to that, you see this one, we can do 2 baskets. Simply just connect 2 baskets together and then fill with rock. And the rock will just push it on opposite directions and then keep the gravity on top. So in that case, we can get it with more loading. So, you know, the basket will be more stronger with more bearing pressure or bearing capacity underneath go support it. So till we get enough bearing capacity for as this one, and then we'll do a wall on top, and then you can do either a building or parking or bridge on top of that along the water, and you can go close enough to the wall. So that's the solution for something in front of the ocean. With a strong connection, especially for landsliding or seismic situation, even there is any situation like that, you know, the system will help you with that. So that's a real situation, and we just value the engineering, change the pails. You see, we connect those 2 pails together so that we can just cut off the pail, the panel about underneath of the ground. So don't need to go that deep. So that will help you to solve the problem easily. You know, if you don't think that's safe enough, you can also just do another way. So that's another option. You know, we get the MSE system replacing those 2 panels, concrete panels. You can compare, see how the 150 millimeters of the MSE comparing to the other side. So the original design was very, very strong, thick and deep, and they get so much concrete used. So while you do a wall in front of water, you also may need some waterproof system, and we do have technology to get the panel to be waterproof. If you require a water absolutely proof from the other side, we can do the plastic panel and with the rubber shim and the sliding anchor so that we can keep the other side dry. So To summary, some of the advantages you see reliable, so against the landsliding seismic, and especially the overall cost is saving a lot, and environmental friendly, especially for 700 kilometer of giant seawall. If everyone interested in more information or have any question, just either just scan this code for the website and contact me for partnership. Thank you, everyone. Yeah.
Thank you, Hartwin. Thank you so much for delivering the presentation on innovative Protect MSE walls, alternative seawater solution. That's really, really insightful and then highly informative presentations. So I may also invite the others, if you have question, please feel free to share your question on Q&A chat anytime, on Q&A chat box anytime. So right now I'm going to invite our second speaker, Layo Haksui, Regional Manager, Senior Engineer, Factor Corrosion Technology Ltd. Haksui is a professional engineer in Ontario and New York and president of the Canada Structural Engineers Association and a certified cathodic protection specialist. He brings over 25 years of experience in concrete evaluation, repair, and corrosion protection, focusing today on galvanic corrosion protection for precast pre-stressed concrete. So without further ado, please feel free to deliver the presentation. Haksui, you have the floor.
Thank you so much. Thank you so much, Dawi. Thank you so much, the board director. Thank you, chair. Allow me to speak here. I'm going to share my screen. Host disable. Okay, I think I need to. Dawi, can you allow me to share? No, still disable me from sharing. Can you allow me to share?
Dibantu untuk sharing, Bulis.
Yes.
Yeah. Okay. I cannot share. Like the host need to enable me.
Yes, maybe Mr. Ade or Ibu Bulis can help, yeah? Okay, please.
Yeah, sounds working now.
Yeah.
Sounds working.
That's good.
Yeah, I think that's good. Okay, so I'm going to bring over here. Okay.
Yes, we can see
Very
that.
good. Yeah.
Can you hit full screen, please?
Yeah. Okay. Go back here.
Yes.
Minimize. Okay. Okay. Full screen. Good now. Good. Okay. Is that all good?
Good. Yes.
Okay.
Good. Thank you.
Yeah, thank you so much. Really, I appreciate allowing me the time to speak here. We appreciate. Thank you for the introduction. Thank you, Davi. Thank you, the board and the chairwoman. And so I'm going to talk today about how we could prevent control corrosion in precast concrete, and how we can extend the life of precast concrete. Like the chair said, we we grow, we green, we sustain. We do that, so we can do for piles, for the poles, for precast beams, a slab. And like a little bit introduction, like about vector, we've been involving a lot in the industry. So like ACI, ICRI, Structural Engineering Association, PTI. So we would like to bring our practice, our best practice in North America, in Canada, to Indonesia, how we could repair, how we can extend the life of our structures. So we will help the industry in Indonesia. Um, and talk about so we learn a lot from our past. We learn a lot of lessons. So we being prepared for the past. We started 65. We started to do repair in 1978. So we've been doing repair for 30, 40 years now. So we learn a lot from the past. And so we learn from other people's mistake. We learn from other projects as well. So we know like for marine piles, when they have been there for some time, then you have some repair to do. But if you just do a conventional repair like this, and then we're going to see adjacent concrete start to, sorry, yeah, I don't see the, sorry, okay, that's fine. So I don't, why, okay, it's fine. This pointer, okay, that's fine. Okay, so you can see like well we could do the you could do repair, but you're going to see problem later on quite fast, and maybe 3 years, 5 years, average on average. I know most structure in Indonesia now is new, but you're going to see more and more inventory, more and more older structures to start to see spalling, and we could help to repair. We help to extend the repair cycle. You will reduce a lot of life cycle cost. And so, like on the right, you see some people do a simple repair. Well, the jackets. Well, if you have the chloride in the concrete already, it doesn't last long. In a few years, whether it's epoxy, whether it's carbon fiber, the jacket will be torn away. So we learn a lot from the past. But why we have corrosion? Well, how do we get our steel? Well, we get our steel from iron ore, from iron oxide, right? And we put lots of energy into this iron oxide. So in the steel, there's a lot of elevated energy. So it will go back to its like iron oxides. It could be 30 years, could be 50 years. But what we could do is we can delay that process from 30 years to say 100 years, 50 years to 150 years. We can do that. So we could use less concrete, less rebar, and then we could conserve the environment. And talk about repair, we've been doing repair like for 30, 40 years already, so we know what's going on. Well, when you do a patch repair, well, you can like, especially like in Indonesia environment, you have a lot of sea, a lot of islands, a lot of structure by the sea, seawall and piles. When you do repair, you may cause more corrosion in adjacent concretes like that, and then later on then start to corrode. So we've been doing a lot of research in the past. So different technology, which one lasts longer, which one works the best. So like you can do control or do nothing, just conventional. You can coat the rebar, you do epoxy coat the rebar, or you can seal the surface, seal the concrete surface, or you can add in this active galvanic anode into the concrete. All these options will work to some extent. Like the rebar coating will help reduce the corrosion by 40%. Sealer can reduce that by 60%, but the galvanic anode will reduce the corrosion by 80%. You still have some corrosion there, but you're going to reduce a lot of corrosion, and then that's how we could extend the life, say from 30 years to 100 years. And talk about repair, we've been doing lots of repair, and then we know, I think it's a little video here. Let's see if the video work. Okay, sounds like the video doesn't want to work. But anyway, that's fine. So when we do the repair, like here, we basically just we're going to have the problem of adjacent concretes, and then we will cause more corrosion. By adding the anode into the concretes, then we have no problem. and so it will attract all the corrosion to the anode, and um, it's not moving. Why my interesting? Why my slides kind of frozen, right? I moved my slide already, but do you see my slide moving? Sounds like I moved my slide. It doesn't go.
Yeah, yeah, we see still in the same page on
Yeah,
repair and institute a node.
You want to
yeah, but
try
when I
to play the video. Try to play the video here first, and then maybe.
mm, yeah, sounds like I need to exit. Looks like okay, video.
No, above.
No, it doesn't want to do. Uh,
Oh,
so you can see I do this, but it doesn't want to move. Like you can see this moving, but this doesn't move. You can see the slide moving to next one, but it does the I don't know why. Mm, maybe it's going to exit first. I'm going to reshare. Um, I'm going to reshare. Um, so we were here. Okay, let's start from here. So we just forget about that video. Um, okay, so we talk about this repair. We talk about piles, these precast piles. You see, actually, we call this necking, neck. So like a large corrosion, this 30-meter pile. The corrosions are focused on this 1.5 meters around here. In a tidal zone, splash zone, and it becomes
It
smaller and
seems
smaller
that
and
we
smaller.
lost Hashui now.
You lost me?
Mm,
You lost me?
okay.
You cannot can you hear me?
Still working, sir?
Now, yeah, you're back now, so we can
Oh,
hear you
really?
now.
Okay, my bad.
Yeah,
Okay. Let's keep.
no worries,
Can
please
you
go
see my
ahead.
screen?
Yes, I can see. We can see your
Okay,
your
so screen shows the
screen.
pile, the necking of the pile, right? Necking of the pile. Okay, let's keep going.
Yes.
So you see the necking of the pile, and so this is what we see a lot. And then, and talking about history, we've been doing a lot of this, and also working together with the DOTs like Florida DOT, Virginia DOT. They realized their piles. Well, they've been doing piles in the 80s, and then they do epoxy jacket, the concrete jackets. But later on, they found that when the chloride already in the pile, you do a jacket, like give this a sick person a cloth. It doesn't really address the cause of the problem. So that's why later on in the 90s, they know it's not effective. So they concluded only the jacket with cathode protection is permitted. Otherwise, better just don't do it. And then you can still see what's going on there. In 1999, also Virginia DOT. So they also say the jacket alone, concrete jacket, epoxy jackets, it's not adequate. So it has to supplement with the cathode protection. So we learn a lot from the past. And so that's we put in this system there in the tidal zone, splash zone. We're going to have a jacket. We're going to add the anode into the system here. So this is the anode and it's a jacket, and we need to connect the anode to the steel that will control the corrosion. Like for this 30-meter pile, we only need to protect this tidal zone splash zone, the 2 meter. So we target this corrosion where it's needed. We target the protection what we want to have. And and also even though below the seawater, like in the sea, below seawater, either concrete pile, steel pile, they all still corrode, but to a slower rate, slow corrosion rate. And That's where we still have this like bulk anode under the seawater. So that will control the corrosion, whatever is on the seawater. Um, so we get increased protection. And we've been doing a lot of work in Singapore. Like one job, it's like a shell refinery plant on an island in Singapore. And you can see the piles. They try to do jackets. It didn't work well. And spalls. So they have 130 piles there, and so they need to provide protection because Shell, so they make lots of money, right? They pump lots of oil, they refine lots of oil, and so they make lots of money there. So they don't want to interrupt their operation. Every day interruption costs them lots of money. That's where they decided to go with jackets. And they have options. They could do like when they at the evaluation stage, they actually think about a few options. Well, what if we should do nothing? Just do whatever we've been doing in the past. So then they have to come back every 3 4 years to repair. Average repair lasts about 5 years, average. And precast concrete lasts longer, definitely. But the average repair like 3 5 years. So they know they need to repair again and again and again. So then they go to other options like in the patch repair, they put in the galvanic anodes and also where they have sound concrete. So they know even the concrete sound. Hello?
Yes, go.
No worries.
Can you
Please
still
go
hear
ahead.
me? Okay, this is recording stop. Okay, that's fine. This could say recording stop. Okay, that's fine. So we can put in like this arrow in the patch. We can also in good concrete area, like in good concrete when we know the concrete is sick. So a problem there already. So we can actually can give this concrete some injection, like when we're sick, we get some injection. So we can drill a hole, we put the anode in the hole and connect to the rebar. That will control the corrosion, control the cancer cell there. And so uh, and, and you have another option what you could do. We can do for global protection, like for 20 years protection. Well, you do a jacket, and then you have jacket in the you have the anode in the jacket, and then you have this anode under the water, so that can provide you 20 years plus protection. But if you want a longer, is adding more anode in the jackets. So that will give you 30 years, 40 years global protection if you like. And that's what you see. Like you see at the tidal zone, we use this jackets. You can see like in the dry area use less anode, but right at the tidal zone splash zone use more anode. So you see, then we have jackets, and then we also need to connect to the rebar and stop the corrosion. Once finished, it's like this, like a pretty new, pretty good jacket there. Um, and then, well, we learn a lot from our past. We learn from our mistakes. That's why we think we could actually use anode for new construction. How does that work? In corrosion, well, it takes time for the chloride, the salts, get to the steel level to corrode the steel. But if we introduce galvanic anode into the concretes, so it will make the steel a cathode. It will expel away the chlorides, and you will generate hydroxide ion around the steel. So that will extend the repair cycle to 20 years further. And for example, here's one of the job we work in Puerto Rico, and it's a ferry terminal. So they knew they have the problem. The old structure was 35 years old, so they have to replace it. That's not good. So they want this last longer. They want this repair repair cycle at 35 years, and then another repair cycle they can last like 75 years. That's what they really want. So what it could do is they know the problem is literally at the tidal zone splash zone. So they can actually target just around here when they precast this pile. You can see that's the head, and then then they put arrow around here, the tidal zone splash zone. They will be able to delay the repair cycle from 20 years to 40 years. And like this, they have all the rebar cage, they install the anode there, and then they cast concrete. And, then they drive this pile into the sea, and that's pretty good. Then they will last longer. We also do a lot of this for like seawall. For seawall, similarly, the only problem is really a tidal zone splash zone. That's where when we precast the paddle, we install like this green thing, that's the galvan anode, into the seawall. So that's a tidal zone splash zone. And once we do that, and that seawall will last 50 years without repair. And that's it. Thank you so much. Like the chair said, well, we grow together, we green, we sustain together. And we could do this for piles, for poles, for soffit beams, sea walls. And thank you so much. And we can do ours together. If you guys interested, later on, I could send our evaluation sheets. We could actually can give you a continuing education certificates. Thank you so much. I will turn to you, Dewi.
Thank you so much, Haswe. That's really excellent. Thank you for sharing the presentation on protection of precast element to extend the service life and reduce life cycle costs. It's really fantastic to hear about the solution technology that you can protect 20 years plus protection or 30 and even 40 years, and also for the seawall, 15 years that we heard earlier. So thank you again. So now we will move to further presentation. Next presentation will be delivered by Antoine Norison, Regional Manager Asia Pacific of Jetek Scientific Inc. And he will be deliver presentation on revolutioning the concrete industry. Little bit background about Antoine. Antoine has 16 years of experience in large international infrastructure projects across Asia and holds a master's in international business management. He specializes in concreting and formwork systems and has worked on major projects like the Hong Kong, Kuchai, Macau Bridge, and Melbourne Metro extension as well. So without further ado, I invite Antoine to deliver the presentation. Over to you now, Antoine.
Good morning, Dewi, and good morning, members, dear chairman, chairwoman of the association. And thank you very much for having us, for having me this morning. Dewi, I will share my presentation, but I'm disabled to share my screen. Could you activate the sharing, please?
Yes. Adi, can you please help to open the access, please?
Dewi?
Yes. Can you try again, please, Antoine? Hi, Antoine. Are you still there?
Okay, now I can share my screen. Yeah. Looks like I'm not the only one to have connection problems this morning. All right.
Mas Adik, nggak bisa Mas Adik?
You have the access now?
Yes, it's fine.
Yeah,
Can you
I
see my
think
screen?
you have the access now. Yes, we can see your screen now. Please go
well.
ahead, Antoine.
Let's crack on then. Thank you. Good morning, everyone. So my name is Antoine Orson. I represent the company Geotech Scientific that we just introduced. At Geotech Scientific, we are on a journey to revolutionize the way the concrete is tested on site, in labs, in the precast and pre-stress sectors. And we are strong of our 15 years this year existence. Initially, Geotech is a company that has always developed and manufactured its own in-house concrete technology, non-destructive technique concrete technologies. Are from Canada, obviously based in Ottawa. We have been awarded many different awards along the years for our works and innovative products put on the markets, and we are very happy nowadays to be following 15,000 projects in the world with more than 10,000 users in 85 countries. In the region of Indonesia, unfortunately, we are not yet very strong in Indonesia. We have a few projects, a small foothold, small footprint, but we have many projects going on as we speak in the Philippines, in Vietnam, in Malaysia, and in Singapore. And like we explained, I am also used to live in Hong Kong for 12 years, so I know very well the Southeast Asian region. Moving on. So this morning, what I would like to present you is our wireless concrete sensors for the monitoring of temperature and strength in real time. All right, so how does that happen? Well, as you can see on the screen, this is a little gizmo, a little device that is totally embedded in the concrete. That means it is totally covered in concrete. You don't see it anymore, you don't recover it, it is sacrificial. What is this sensor made of? In the black box, you have a battery for 4 months, a Bluetooth antenna, a memory for the concrete data, and you have a temperature sensor. You have a second temperature sensor at the tip of the cable. So that means what? That means that one sensor has two temperature and strength data monitoring points. Okay, so it's like a two-in-one, which is particularly useful when we do large casts, large formworks, large pour, mass concrete, where you can basically monitor the temperature and the strength from the two different locations, like the top and the core, top and middle, allowing you to have more data about temperature, strength, but also temperature differentials. Also in this sensor, activation channel to switch on and off the sensor when you are preparing before installation. There is a rubber installation strap that is extremely strong, up to 2 tons tensile force. And last but not least, you have a QR code for the tagging of the sensor with the mobile app. So this picture perfectly illustrates what I just explained, the 2 points of temperature and strength monitoring, the QR code for the tagging with the mobile application. 60 days of data is the memory, will be stored in the memory of the sensor. The data are automatically collected by the sensor from the concrete every 15 minutes without the help of anybody. In terms of installation, extremely straightforward, very user-friendly. You tag the sensor with the app, you install the sensor on the rebar. If there is no rebar, you just sink it manually in the concrete pour. You pour your concrete, you get the data immediately on the smartphone. So this is the hardware. Now the web tool, the software tools. First of all, the mobile application. Mobile application is called Smart Rock application. This is an app where you can create your projects, your areas, sections, subsections, tag your sensors, get the data instantly via a Bluetooth signal with the sensor. So the sensor is in the concrete, it's connected to your mobile phone thanks to the transmitter, the Bluetooth antenna, and communicates the concrete data via Bluetooth. The range is 12-meter distance. Okay, we have another solution where it's called long range, using a gateway where you can extend the range of the signal to be able to collect data on remote if necessary. okay? But already from the app, you can get the results, create graphs automatically, send reports, share the reports or data with your team members, with your clients, with the engineering firm, etc., and manage your user. The second web tool, software tools that we have is called GIATEC 360. It's the next level of analytics, basically. So you will understand the sensor is connected via Bluetooth to the app is connected to the internet, and will send the data directly to the GIATEC 360, which is a cloud-based dashboard, okay? On this cloud-based dashboard, you will be able to spend more time to analyze the results, the data, plot data together, isolate sensor, pores, manage your users, manage the mix that you're using, use the artificial intelligence features where we can predict temperature and strength. We can also model. We have some AI thermal model features that can model your pour before you pour your concrete itself. And this is it for the software tools. So I presented you the hardware, which is literally the device that you put in the concrete, how it works, how it's installed, and how the data are collected, exploited, received, analyzed by our systems. Now, of course, this is only a little and very brief description. You will understand our sensors collect temperature automatically. We use a thermistor. It's a type of thermocouple, much more accurate. How do we get the strength data, you could ask? Well, this is simple. We use what we call the maturity principle. I don't know who of you is familiar with the maturity principle in this room. Maturity is a standard, it's a methodology, most accurately, that was invented in 1959. So it's not new, right? We have not invented it, and to get the strength data, there is no magic. Okay, so that means that we use this standardized method that is standardized by many different standard body worldwide, ASTM, CSA, Eurocodes, Australian codes, Indian codes, Japanese codes, ACI. I know the ACI in Indonesia is pretty recognized and used for compliance. So this is definitely something that you can use. The standard most commonly used for maturity method is ASTM C1074. So what is the maturity principle methodology tells us? Well, first of all, everything has to do with the temperature history of the concrete while it is curing in order to estimate the strength development. It's a non-destructive method that will estimate the real gain of strength in real time for the fresh concrete. And it's particularly useful for the first 14 days. So it works, you understand, data for 60 days, but the first 14 days are the most critical in terms of operation. Striking the former, soil coating, striking the molds, lifting, pre-stressing, de-shuttering, etc., etc. Okay? So the maturity method will help us to estimate in real time the strength, so critical decision can be made on time and even more accelerated. But most importantly, this method is pretty accurate. While being conservative, it is still pretty accurate. We're talking about more or less 1 MPa accuracy. 1 MPa accuracy is extremely accurate, actually. I think you would agree. Basically, to be able to use the maturity and the strength data, you will need to do what we call a maturity calibration. This is a calibration that we do in a lab. That's not the sensor that we calibrate. This is the mix design that we calibrate. So I'm not going to spend time on this to explain this morning, but all you need to know is during this calibration, what we are doing is correlating the temperature and time factors to the strength gains over this time, okay? And we build the maturity strength relationship that will be a curve of reference for a particular specific mix. Moving on, you will understand maturity principles, so using the science and using our advanced concrete sensor What we're trying to do here is to basically close the gap. Close the gap between what? Between the way that the concrete is tested on site in precast factories for very critical operation like pre-stressing, bring accurate data to the users, to the batching plant owners, to the factory owners, so they can do a better job, faster, more efficient, without compromising quality. And we call this efficiency. So what benefits using our sensors with the maturity methodology? Well, there are various, but obviously productivity. Having the strength data and the temperature data in advance allow you to get accurate data that you did not have before. And those data will help you to keep your planning under control, accelerate your production lines, and reduce your project and reporting time. This is extremely important, especially when it comes to factory where you have several production batching lines and you need to improve productivity. Quality, of course, because you can improve the performance, you can keep the temperature under control, prevent cracks, and again, guarantee the durability of the concrete that you're casting. So if productivity is improved, if quality is improved, then obviously safety is improved. Okay. And ultimately, we have the sustainability aspect. Sustainability aspect comes from the artificial intelligence that we are using in our system that is analyzed by our AI bot that we call Roxy, and that will give us the opportunity in suggesting only opportunity to reduce the cement content in the mix directly related to the CO2 emissions. In terms of applications, formwork removal, post-tensioning, mass concreting, prefab and precast, shotcrete, big application, shotcrete, because it's all about a very early age, heat curing optimization, open traffic through concrete road pavements, etc., etc. Every concrete element deserves to be tested. Now, by experience, if you ask my opinion, the load-bearing elements should be prioritized. So the beams, the piles, the slabs, the post-tension slabs, the pre-stress elements, and of course in your sector, precast, pre-stress, huge advantage for quality control. Last but not least, sustainability. I touched base a little bit already about it. So this is Roxy. This is our first AI program for concrete testing. Roxy can do many things. You understand we've been a pioneer in the industry to use AI with advanced technology for the concrete. And we are now strong of more than hundreds and hundreds of millions of data points in concrete. This is actually factual. I think the exact number is close to 200 million points from the fields that have not been downloaded or whatever, developing our own algorithms. And we can use Roxy, so the AI robot, to do various things, to suggest pouring times, to validate the mix, but also after use of the sensors in your concrete to analyze how the mix is performing. Based on this performance, not overperformance, not underperformance, just normal performance, we are able to establish correlations and propose a cement reduction in kilograms per cubic meter. Okay? From there, the direct relationship to CO2 emission can be made. So if 3 or 4% reduction of cement is suggested and is actually applied in the mix design, this can lead to hundreds and hundreds of tons of CO2 saved, just like that, without the need of complicated formulas, softwares, engineered staff, and whatsoever. Just by following our suggestions, just by following our standardized methodology data that you can rely on. All right, this is it for me. Thank you very much for your attention, and Dewi, over to you. Looking forward to your question and answer.
Thank you so much, Antoine, for sharing the presentation on revolutionizing the concrete industry. That's really insightful and then very, very informative. And then I invite also the other participants who like to ask further about the presentation that already delivered earlier. Feel free to share your question on Q&A box at any time. Now I will invite the last presenter, last but not least. I'm pleased to introduce to Phil Sherless. He is the Director of Global Sales and Business Development, Lodestar Structural Engineering Ltd. Phil leads global expansion and licensing for Lodestar's innovative precast concrete building systems. He specializes in market entry strategy, contractor training, and client development, focusing on faster, safer, and more cost-effective building solutions worldwide. So today, Phil will deliver a presentation on Lodestar Structures Building System, durable and efficient precast solution for residential, commercial, institutional, and building construction. So without further ado, I will over to you, Phil.
Good morning, and thank you so much. First of all, I just wanted to say that I'm honored to be here. It's incredible opportunity to be in front of fellow precasters from the other side of the world, and to share our technology and to collaborate on solutions. The previous presenters and myself collaborating on methods and technology available in Canada, and hoping to introduce it into your markets. Attempting to share the screen, it's locked for me as well.
Okay, Aditi, can you help to open the access so Phil can share the screen, the slide on screen? Thank you. Hope it works now. Maybe you can try again, Phil.
It still says that it's host only.
Okay. Yeah.
Perfect, thank you. So
yeah, we can see your slide now on screen.
You can? Thank you. So as mentioned, the product that I wanted to introduce you to today is a precast concrete building system. The components of the building system made as a precast solution in a precast plant, incorporating all the tests, all the quality assurances, all the parameters that would be subject to precast, allowing you to do that, produce the inventory, and then bring the inventory to site for rapid installation. When we talk about Lodestar, just to set the table and explain what Lodestar is at its simplest form, Lodestar it's a building system. The building system, when assembled, has the ability to produce residential, commercial, any building today practically that you're building using traditional materials, whether it's a metal, a wood, a cast in place, or even a tilt-up. Our system can be used below grade and can be used above grade for projects like I mentioned, but also parking garages and other applications. Lodestar, the product itself, is reinforced concrete. Everything about the product is produced in a precast plant using molds, so traditional to what you're used to today. The products are engineered building materials. So when it is produced in a certified plant and delivered to the site, the certification goes with it to the site, making the process or the construction process a lot easier, a lot more efficient. It does also solve or satisfy the building code requirements to be certified ahead of time in your market. So it accelerates the approval process as well as site. Because it is off-site manufactured, it can be produced ahead of time prior to installation schedules, delivered to site for rapid installation with less resources required at the site. When we look at the Lodestar system, and just to give you an understanding of the speed at what Lodestar can come together, we're consistently achieving rates of about 90% savings on site for construction. And how we do that is we leverage the ability to produce precast bases, precast structural units, and then other precast components, reducing or removing the need for that type of work to be done on site. So when the product is delivered to site, it's just a matter of installing. Even the process and how the installation happens, and I'll just share a video to show you one of the illustrations. The method on how the installation happens is a simple crane in place solution with the precast modular components. And what we're seeing here is we're seeing a project of about 15,000 square feet. The base units of 15,000 square feet were installed in the first part of one day. So we're about 6 hours into the day at this point, and we're starting to install the superstructure, the structural elements of the building. The important notes there is you can see that they're on the ground. There's minimal ground crew, and the tools that they're using are simple hand tools. The crane is doing the lifting, putting the units in place, and at the actual site or the groundwork is really just a bolt together connection process and using wrenches, a couple ladders to connect and disconnect. But they are able to install each one of those modules in this example is about 436 square feet. So we're able to install that much about every 7 to 8 minutes. And then to support the rapid installation, because the process happens so rapidly, we have developed a lift system that allows us to rapidly lift the products, deliver them to site, and then lower them. You can see on the left of the screen a real life example there of the units coming into place to be able to feed the crane to make sure that the crane has zero downtime and that construction can go ahead without delays. The entire project in front of us here today is 15,000 square feet, and that was completely done from start to finish in 28 hours. So what you're seeing here is the final day of the project, closing out the 28 hours, using simple hand tools, one crane operator, a small amount of ground crew, and also, again, minimal tools, minimal equipment. The last day here is a matter of just putting the units apart. You can see how the units themselves, they do illustrate here that they can be stacked vertically, multiple levels. They can be elevated as well. We have extensions that allow the modules to be lifted up to give you extra headroom to add custom features to the projects. We also have, I'm just going to fast forward for the sake of time. We also have a solution available allowing a precast concrete wall panel solution to be installed in the products as well. All of the components that we have that we introduce into the building system are predetermined, calculated, and allow for on-site installation with, again, minimal tools and equipment. The wall panel system that you'll see coming into the project here, as fast as we can bring the wall panels over to the project, they're able to be sat down on a metal bracket that there's a corresponding bracket on the panel, then a bracket on the Lodestar system. And between those two, you can install, again, hundreds of square feet of wall panels on a building project, about 5-6 minutes per panel. When you look at the projects that we've just as examples, this is a project here actually in the office that we're in here in Canada, and we were able to do a 6,000 square foot project in 4 hours. This project we did use 2 cranes, so even if we extrapolate that out with a single crane, you're doing about 6,000 square feet of foundation and 6,000 square feet of structural framing in a period of about 8 hours, again with a modest crew and very modest equipment. It worked out to at a rate of about 1,500 square feet per hour on this project. The one that we just saw in the video, this is the breakdown of the analysis of that project. And again, speaking to the 90% reduction of time required on site. The project itself was completed in 28 hours, 15,000 square feet of bases, 15,000 square feet of structural units, and a modest crew. We were able to do 536 square feet per hour on this project. Again, with a very modest single crane process. When we look at the products itself that are available, so you saw 2 of them, one of them being the precast base, the other one being the precast structural unit. We also have, as I mentioned, the precast architectural wall panels. We have a metal, it's a metal offsite manufactured panel that again sits on or clips onto the building in rapid succession. And we also have precast roof panels. So the product itself will round out the major superstructure of the building. So you start with your foundations, again, a very simple bolt together solution with the structural unit. The structural unit is brought in, sat down and bolted together onto the base of the unit. For projects where the base situation may have challenges, you may have situations in your market where the bases aren't suitable, definitely you can use cast in place footings or other footing solutions and mount our structural system on. The wall panels, same scenario. The wall panels can be produced ahead of time with an architectural finish. They can be produced ahead of time with the windows and doors blocked out. So when they do come to the project site and they're sat in place, again, minimal tools, minimal equipment, the product itself acts as a finish barrier on the outside of the building. The concrete roof panels that would then cap this very top surface, if it's a 4-story, 5-story, 6-story building, on the very surface of the building, after you put your membrane and your waterproofing, you would put down the precast concrete panel on the top of the building. That allows you to have concrete protection on the top, so UV, any debris, any storms, any weather, the building is protected. But it also allows you on the roof to then use that space for gardens, for patios, to capture rainwater, to mount solar equipment, wind power generating systems, or just your mechanical systems for the building, being able to put on the rooftop, where a lot of traditional would be down at the ground floor or using another solution. One of the products that we've introduced as well is this is a single module decked out with the precast, or sorry, the metal frame panels. And they're very similar to the precast concrete wall panels. So they're designed off-site, manufactured. They're about 100 square feet per panel. And again, they are brought to site and just sat in place. You can see on the left of the screen, there's a skeletal view just to show you what the framing would look like. On the right side over the green, that's the finished panel for the Canadian industry, requiring a certain design, insulation, and exterior cladding and weatherproofing. We also have a system that allows you to put a beam in between. So when you have our structural modules set in place, there's a beam system that can go in to support infill material. And the infill material could be hollow core slabs or other beams or other slab systems that are common for your market. We do also have a double T-slab or a T-slab solution that allows you to span in. A benefit of using this system is that it also allows you then to customize the width of the building, the spans, to give you those maximized spans. And the illustration here on this video, on this picture, between the columns on one of our larger units, you have an uninterrupted span of about 27 feet on the structures themselves. When you introduce the hollow core slab or the T-slab, then it's the capacity of those slab solutions, which could be in the area of 10.5, 12 meters of span, again, with no columns, supporting commercial and residential loads. The products itself are commonly used really for any application where today you would use cast in place or metal or even wood frame buildings. So with single family homes, the system definitely for speed would accelerate and surpass any of the other building systems I mentioned. Cost wise, it is 5 to 10% in most cases, lower price on even a single family home or a single building. When you get into the multi-unit residential, commercial, industrial, hospitality, where potentially you have multiple levels, our cost savings and our efficiencies are accelerated with every level you go up. So now you start to save 10, 15, 20% on the material costs. And then you also save on anything that's associated to your time. So if it's your labor, if it's your equipment, your insurances, and just your delayed, let's say, return on investment. When you have a building, if you start January 1 on a building, the sooner you can have that building occupied, the faster you start to recover your costs. Our system allows you to accelerate that return on investment and get people into the buildings a lot quicker. Some of the projects that we've been involved in, building out communities. When you look at the buildings here, whether it's a community built for a developer or whether it's a government affordable housing or different complexes, if it's hospitality, hotels, multi-unit residential, again, a very simple system to design with and very simple system for installation. Every product that we produce in every market that we produce it in The products are engineer verified to pass all the building code requirements in your market. So seismic, wind load, live loads, hurricane, the whole works. Our system ahead of time is verified to work in those markets. We have, as an example, we've been vetted currently in West Africa. We're being vetted in South Africa. We are approved for use in California, USA, for Texas, for Florida, and for Ontario, Canada, and other provinces in Canada that are relatively high in any of those aspects, whether it be seismic or wind, and so on. I believe the wind in Florida is probably the highest that we've been rated for, and that's a Category 4 hurricane experience in there. And then the seismic would be probably California, which is a very high seismic in that region. Some of the projects, again, when you look at the upper screen, you see the skeletal view and then a partial cladding in the center. And then on the right side, when the building is done, it looks as traditional as your traditional building system that you use today, but assembled at a rate of about 90% faster than current building systems. Single-use residential as well. Smaller buildings tend to be a little bit less efficient because of the footprint, but even on the smaller buildings, we're showing a savings of in the area of about 10% on the building platform, and that's just on the building materials and the labor into it, not necessarily the other associated like insurances and equipment that you would need to be on site longer. The way that we do deploy our building system is that we do work through licensed agreements in different countries. So what we'd be looking for and what we're presenting today is the opportunity to work with the precast industry in your markets to license the technology. So we would share the information, the design, all the building systems we have. We would either provide molds and the systems that you require to produce, or we would work with local people in your region to have the molds produced. The territories would be exclusive. So in a market, you would be the only one producing in those specific markets. As I mentioned, the engineering is verified per region. So before the end product is introduced, it is verified. The molds and equipment are supplied, whether it's a local fabricator in country or it's a fabricator that we could fabricate them in Canada and ship them, or a mix of both. And then training and resources also made available to you as well. When we look at the plant, this is a traditional plant for the building system. So we have traditional molds. You see the rebar that goes in, and we do use a self-consolidating, so an SCC concrete, which allows you to do a single cast, so no cold joints, no seams. The product goes in, very simple, very rapid, and we are turning the molds on a 24-hour cycle. So every day we produce a unit, we take it out the following day, we produce another one that day and take it out again. So you could produce up to 7 units per week per mold that's applied in the building system. When we look at Lodestar, one of the benefits or some of the benefits for Lodestar would be that because it is precast concrete, you are naturally competitive with the alternatives of the competitive markets, because you are using local labor, you're using local concrete, local reinforcing, and all the revenue that you as a local producer producing the product and selling the product, that revenue and the labor and the work and so on all stays in your local community. So not only are you building your community literally by using the building system, but you're also benefiting the community by keeping the revenue and the profitability in your markets. The components I mentioned are designed to comply with local building codes. If there are any requirements for the system to be adjusted, modified, redesigned in any way, our engineers in Canada would work with local engineers in your market to ensure that the building system complies with all the required building codes, and that when introduced in the market, it does meet and satisfy that. When you're looking at precast, and I know I'm speaking to the precast industry, obviously precast in a building system would be strong, would be very durable, and it'd be a building system that would last. Some of my co-presenters today were talking in terms of 50 years, hundreds of years. Precast concrete, we know, is one of the most durable building systems in the market or available. With our building system, because it is primarily encased or it's built into a building and cladded on the outside, therefore it's protected even more, that the infrastructure of the building system would be rated in periods of hundreds of years. When we look at the building system, as we design every component of the building system, we ensure that we're designing the system as lean as we can. So we're taking out as much of the concrete, as much of the rebar, as much of the labor to produce and to assemble and to use it. And we're making sure that it requires the minimal amount of equipment to either manufacture, deliver, or install the building system. So every component that you have is maximizing the efficiencies, not only at our level as a precaster, but the level to install for the builder developer, and then at the level for maintenance and long term. When we look at the building system, we can look at a whole series of features that we're adding, features that we're taking away. But when you look at the building system, the idea behind the Lodestar building system is to give you a system or provide a system that is familiar with the community. So it's a reinforced concrete solution. It's something that today is used in practically every building that's built. Really what we've done is we've taken that technology, we redesigned the rebar, redesigned the structural elements of the products, and then sharing that with you to allow you to introduce it into your markets. There's nothing new, I would say, in the building system. It's cement, it's aggregate, it's water, it's rebar, it's labor, and it's molds. Everything in the building system you would resource from your traditional suppliers. There's nothing you're coming back to us in Canada to purchase. Therefore, again, all the revenues and all the profitability and the competitiveness stays within your market to make sure that you are doing the best for your community and the best for your own company. When we look at what we're reducing, and I mentioned the materials, again, not only at the manufacturing site, at the construction site, and then again at the installation and the ongoing maintenance, we're making sure that all the material waste of the building system is reduced. The construction schedule, when the products are produced ahead of time and you know the products are available for your building, that reduces or eliminates any risk of schedule concerns where the product are delivered and they can be assembled immediately, whereas a cast in place or alternative system, sometimes you do experience delays on site due to weather conditions or due to a delay in equipment arriving or tool maybe breakdown or not having the proper tools. Our system, because it's produced ahead of time, you know when the builder asks for it to be delivered and the schedule is set for it to be installed, you're doing it at a rate, as I mentioned earlier, thousands of square feet, either per hour or per day. The system does go together with minimal training. It is a bolt together solution, so minimal resources, minimal training requirements. So even in our industry, and I'm sure you share similar experiences we do in Canada, with a reduced or lacking skilled or just a lacking workforce, you can build more buildings using less resources of labor. Not only that, the labor does not require the experience and knowledge that traditional building would be. You can train staff to put the buildings together in a very short period of time. It's a bolt together, a very simplistic system that after a couple of days to a week, they become as knowledgeable as any expert that can be building these buildings anywhere around the world. When you look at it, associated costs in the building system, then as you make the building system faster, the associated costs that go with a traditional building, such as your construction insurance, your workplace management, your even your governing bodies that have to do inspections and approvals on the system, it negates the need for that or accelerates that process for saving you a lot of money. So with that, what I'll do is I'll invite anybody in the market that has any questions. By all means, please, I invite you to reach out directly or reach out through the organization and share your ideas, share what you're looking for in your markets. And I would love to have the opportunity to collaborate, to share more information about Lodestar, but also to work with you to identify how Lodestar can be introduced into your market and the benefits it will provide. So thank you, everyone. Thank you for your time.
Thank you so much, Phil, for the excellent presentation. So before we move forward to Q&A session, which leads by Pak Dudung, I would like also to make a summary from 4 presentations earlier before that have been delivered by the Canadian speakers and presenters. So we have 4. The first is EarthTech Group. They are specialized in mechanical stabilized earth and geosynthetic reinforced soil wall system. They offer end-to-end services from design to construction, and their proprietary e-wire and e-panel solution use sustainable geogrid materials to create modular high-performance structures tailored for seismic and site-specific needs. And then the second, we have also today Vector Corrosion. They are a global leader in concrete preservation, known for innovative solutions like galvanized shield embedded anode and Norcure electrochemical treatments, delivering long-term corrosion protection with award-winning designs. And the third presentation, which was delivered by Jetek Antoine. So Jetek Scentic provides smart IoT-enabled concrete sensors that monitor strength, temperature, maturity in real time, supported by AI-driven analytics to optimize maximum designs and reduce CO2 emissions. And last but not least, we have also Lodestar's presentation from Phil. Lodestar modular precast concrete building system over fast, durable, flexible construction. And the system supports stackable, expandable design, reduce waste, labor, and environmental impact as well. So it's ideal for rapid, sustainable builds with consistent quality and cost certainty. So hope you enjoy the session, the presentation session today. So now we will move forward to the next session, Q&A session. Thank you so much again for all the speakers for the insightful presentation. We will now open the floor for the Q&A session. Please submit your question through the Q&A box. And this session will be led by Pak Dudung as the moderator. So over to you, Pak Dudung.
Okay, thank you, Ibu Dewi. Thank you for your all presentation, yeah. For presentation, Mr. Harbin, Mr. Haushu, Mr. Antoine, and Mr. Philip, yeah. Sorry, my spell not as good, yeah. But I want to present it about AP3I, yeah. Yeah. Do you have already looked for my presentation?
Yeah.
Okay, thank you. Yeah, first I want to present it about AP3I. AP3I is Asosiasi Perusahaan Pracetak Indonesia, or in English, Indonesian Association of Precast and Distress Companies. We want to share about profile and then our product of our members, and the capacity of the production. Our address in Jakarta, yeah, you can read in here in Simpina Cepeda, Jalan MT Haryono, number 12, yeah, and East Jakarta. And it is the email address, website, and Instagram, also YouTube. We have 4, yeah, okay. About profile association, for the AP3I, along with PRECAST, yeah, the construction world, the member of Company of Indonesian Precast and Distress Expert Association, as the name is EAP, EAPPI, is separated from EAP's members in the Indonesian Precast and Distress Companies Association, or AP3I Association, which was formed on July 18, 2013. Currently, it is the fourth management term of service 2022 until 2025. The AP3I Association has been reaccredited at the LPGK Ministry of PU, or the Construction Service Supply Chain Association. The accreditation letter number you can see in here, yeah. And then this is our pengurus, yeah. And also this is a member, yeah. Also, yeah. Next to the activity. The activity of Asosiasi AP3I, we have so many activity. First, about SNI. SNI is Standard Nasional Indonesia. We have draft or R0 for standard internal Indonesian national standard. We have planned 70 product. Realization in 2023 2 product and 2025 with the R0, R0 4 products. So we in the progress 6, yeah, 2 already and 4 in progress. And then the second is a green industry standard industri hijau. For the green industry standard for precast concrete industry 2024, facilitated by Ministry of Industry, yeah. Target 2025, all the members will be give certification green industry certification, sorry. And then the next activity is tingkat komponen dalam negeri or TKDN. TKDN is achievement of domestic component level of precast and prestressed concrete industry. Target all the members can execute the TKDN or have TKDN. And then the fourth, we also have PCI manual. This is from PCI manual from America, and socialization of the implementations of factory quality control manual and precast structural concrete product fabrication. Target we training and we technical guidance for the PCI manual. And then the fifth activity, we also have monitoring and evaluation. Routinely conduct monitoring, evaluation, verification, and validation to members. Yeah, 2024, 5 members, 2 new and 3 members assisting. And 2025, target for 10 plants. Yeah. And then we also have for the 6th activity, first about PUB and PKB. This is a workshop, seminar, forum, FCD, technical meeting, technical guidance training. The activities are reported to LPGK as PKB activities for individual members or PUB for company members. Like today, maybe we after that we also report to LPGK. Yeah? Target for 2025, we have 10 activities. Start from July, yeah, until November, because December so many holiday. Yeah, okay. And then we also activity for audience. For audience, first for to LPGK, and then the second for Ministry of PU, BKP and Industry. Third, Ministry of Energy and Mineral Resources. And then the fourth, provincial and local governments. And the fifth, members of the AP3I Association. We also have so many pameran, ya. Pameran is mean exhibition. Exhibition in 2022, 2 events. Year 2023, 5 events. Year 2024, 3 events. And we have planned for the year 2025, we have 5 exhibition, 4 in Jakarta and 1 in Surabaya. I think this is the picture activity that we already done, yeah, before. You can see in here. This is our members Asosiasi AP3I, and yeah, we have 24 for the fabric, and we have 4 for the pre-stress, and there is 5 for the BUMN, yeah. Sorry, for the construction of house, yeah. And then 1 for multi-melindo, the connection of spoon pile, yeah. Yeah. So the total is 24 and 4, 5 and 1. This is our member. And almost the typicality of production, we have a spoon pile, and then sheet pile, and then for road, for the bridge, for the drain, canteen, and then for the railroad, yeah, for the fencing, for the building, so many system of house, and yes, component retail building, and then building system, pretension system, pole for the electrical, pole for the telecommunication, and then underground in here, tunnel, yeah. You have already have for support at the LRT, MRT, sorry, for MRT, the tunnel, yeah. And then construction, this is for the beach, like a port, yeah. And then system, this is a pipe for construction energy, cable protection, and for the dam, yeah. This is our picture of the production that we already produce. Yeah, you can see regarding the produce of seawall, chain seawall. Now they use a spoon pile with diameter 1.2 meter, and the long is about 24, something like that, with the connection in the edge of the spoon pile, yeah, connection. And also so many bridges we support for toll roads, yeah, for toll road, Jakarta, Surabaya, and then connection until to Probolinggo, yeah. And so many train, turap, seat pile, yeah, and so on. Yeah. You can see in here. This is our typology of product. The main product is spoon pile, yeah. So many product in here, and until more than 10 million ton, yeah. And then the bridge, the second product, and the third product is turap. There is our production in AP3I that we are already record, yeah. Okay. Tiang pancang, spoon pile, jembatan is bridge, and then seat pile and train, komponen gedung. This is capacity production of our members. As you know, in 2019, the maximum we already reached 38 million ton with the 30 members and 82 fabric or plan PRECAST, yeah. And after that, as you know, we have about COVID, yes, sorry. In this year, 2020, there is any COVID, so the capacity go down, and yeah, not come back again to 38, but until now, still a little to 27 million ton. Yeah. The utility of 2024 only 13. Only 11 until 44% the utility of the public. Just the one our member achieved 76%. Our member at Kalimantan for IKN, for the new capital city in Kalimantan, near the company is near IKN, yeah. This is our activity in 2025. You can maybe follow and then join with our activity. There is the schedule in seven exhibition. Yeah, the first at WOCA, World of Concrete Asia, and then the second Indonesia Building Technology, session 1 on July, and then on September, Concrete Show Southeast Asia, Indonesia at Jakarta, Kemayoran. And then we also at September, mining industry, and also at Surabaya, Indonesian Building Technology Expo. And the last exhibition on November, we have Indonesian Building Technology in PSD City. You can join with us if you want, go to Indonesia, and we can discuss about the presentation in a detail, because all the participation today is very, very interesting regarding the project infrastructure Indonesia. Mr. Agus Hari Yudhoyono, AHY, can join with us in Indonesian Building Technology Expo Session 1 on 3 July 2025. Yeah, I think after that, so many activity with Mr. AHY, Mr. AHY as infrastructure ministry, yeah. I think enough. Thank you for my presentation. Kembali ke Bu Deli. Okay, thank you, Bu Deli.
Thank you so much, Pak Dudung, for sharing the presentation, sharing about the profile of the association AP3I, and also upcoming activities, and also the opportunity to explore with the Canadian companies, including with the JetTech, and then Lodestar, Factor Corrosion, and also the first is about the EarthTech group as well. So I think we can also open the floor. If I may check, we can check also the chat box there. So maybe I can help to check if there's like a question there from our audience. Yeah, I think there's one question right now about, let me read it. So to all speakers, if you had to highlight 3 key strengths of your solution, what would they be? So perhaps I would like to invite first presenter, first is Hadwin. Are you still here? Maybe you
Yes.
can jump in and share the most 3 strengths of your solution.
Okay, the first one I would say is the overall cost. the material cost will be around 40% for soil reinforcement, and the overall system cost will be saving about 20%, and easy installation. That's the first advantage. The second one is more durable and reliable. Instead of doing a slope at 70 degrees, we can do it vertical, and we can do for the mining zone for the 102 kPa and 240 kPa for the bridge in Ottawa. So be certified as reliable. And the third one is more environmental friendly, and we can do it waterproof, especially in front of the salted water. We can get more environmental friendly and waterproof, save CO2 if we do the recycled plastic panel. Hopefully that answers your questions. Yeah.
Yeah, thank you so much. So first the cost, so it could be reduced 25% cost, and then more reliable, right? And against engineering challenges. And then the third, it's waterproof, right? So thank you so much, Hartwin. So I invite as well, Haksui, would you like to jump in and then share the most three strengths of your solution?
Thank you, Dewi. Thank you so much. Just like the chair said, we grow, we green, we sustain. So like what we do here with, if we can extend the life of steel structure, like the structures, the precast elements. So, number one thing is with our technology, we can target the uh, the critical area in the precast segments, precast element, precast structure. So we can extend the life of the structures, and then extend the repair cycle. And then the next thing is what we really achieve is reduce the life cycle costs. Think about life cycle costs. So if a structure lasts 30 years, now we allow that last 60 years. So it basically like you really lower the life cycle costs. And the third thing is if we can have all the structure last longer, and we need to use less concrete, less steel, and we're going to have a less CO2 emission. So overall, it's environmental friendly. Thank you.
Thank you, Haswe. So it's protect critical area, particularly on precast and the external life of precast, reduce life cycle costs, and also definitely it will be less reduce the emission, less CO2, and also it's environmentally. Thank you so much for this. So I invite also Antoine from JTech who would like to jump in and then share your most three strengths of your solution products as well.
Yes, thanks, Dewi. Um, Productivity, quality, safety are the three first main benefits. Um, where we touch base is operations, productions, costs, optimization, savings, and most importantly, accuracy of the data in the concrete. Jumping into the 21st century, having all the data literally your eyes into the concrete with accurate, advanced sensing technologies, compliant to standards, with reliable data that can be documented and used to, again, uh, produce better, faster, smarter, safer. Thank you.
Thank you, Antoine. So I make a note here. So it's about the accuracy data, which complies to the standard as well, and then your sensor can also support the productivity to make it more, safer, and of course support the sustainability and really user friendly as well. Okay, thank you so much. And then last but not least, I would like to invite Phil as well. Maybe you can also share about the most restricted of your solution, Phil. Please go ahead.
Yes, thank you, Dewey. Thank you, Dewey. Thanks for the question. I would say that the top qualities of the product, the features of the product would be quality. The reason for the quality is the product is produced in our precast plants. So it's done in a controlled environment. It's done under controlled measures by processes, and it's engineered ahead of time to eliminate any waste in production, any waste in materials and so on. Also, the quality therefore in comparison to other options such as cast in place, you're not weather dependent, you're not labor dependent. It's a process like a production line where everything is done indoors. Sustainability with the building system. The building system is very basic in its components. You're looking at reinforcing metal. You're looking at some aggregates and cement. Very, very minimal ingredients. And the product at the end of its life cycle is something that can be crushed and reused. Because the building system also is a bolt together connection, and a lot of the panel systems do clip on and clip off. If the building purpose or that space is needed for another purpose, the building could be disassembled and moved. So again, you're not building new material, you're just relocating the equipment and material to another site to reuse it. And then the third feature would be the efficiency. And the efficiency, that would be anything from manufacturing, delivery, installation, long-term maintenance of the system. And again, because it's produced in our precast plants, we can take the time to analyze every step of the process, every ounce of equipment or material used, and we can make sure that if it's necessary, we use it. If it's not necessary, we can design it out, therefore making it very, very efficient.
Thank you so much, Phil. Yeah, so the first must be quality, of course, right? And then sustainability and efficiency. Thank you so much. So if I take a look all the four presentations today, there are like similars that I see right now, that those solution is actually really, really environmental friendly, and then sustainable, and then very, very supporting on an efficiency. So it's actually fit with our big topic today. Is about the sustainability future, and then we provide a Canadian technology solution that can support the development of infrastructure in Indonesia. So I would like to open the floor, and also Pak Dudung, if there's like another question as well to all the speakers. I know that conscious of time, we already run out of time, but we can also, if there's any question you would like to add, please feel free to jump in. Don't be shy. But you can also share your question further to all the speakers directly. I believe that all the speakers have already shared their contacts details, the email address, so feel free as well to reach out them if you would like to explore knowing more about the solution, and then explore the partnership as well with them. Feel free to do that. Yeah. Pak Dudung, would you like to add anything that might be amiss?
Yeah, sorry for the yeah, about the question. Yeah, so many in my note in here, but maybe better if I will send to all the participants. Yeah, especially in Indonesia, there is so many island. Yeah, with the condition, the corrosion is very, very dangerous for the infrastructure. Yeah, like pile, like concrete also. And as you know, regarding to Mr. Hashu, yeah, Mr. Hashu,
Yes, Hash.
yeah, regarding in Singapore, I think, yeah, not so different in Indonesia. We have already used the concrete with the cement type 2 and type 5, sorry, type 5. And also we use substitution material for cemented, yeah, like slag, like GGBFS slag, yeah, ground granulated plus furnace slag, and then fly ash, and also we use silica fume, yeah. But yeah, we cannot defend, yeah, the concrete, like Mr. Hasu said, that yeah, we must covering also to the precast, our precast spoon pile, yeah, like for Bali toll road, yeah, There is so many. Maybe Mr. Haisu can propose a detail about maintenance, yeah, for the Bali Toll Road, and also we have in Surabaya for the Suramadu Bridge, yeah. We can see also check. Yeah? Let me check first, yeah. And then the third, sorry, the second for apa? There is a seawall solution with e-panel and e-wire. Yeah, e-panel and wire.
Erteh
Yeah.
Group, Pak Dudung. Erteh
Yeah.
Group Company. The
Yeah.
company name.
Yeah, from Ertech Group. Yeah, from Ertech Group. This is interesting. You use the apa? Recycle material. Yeah. Good. We use plastic in here, and yeah, maybe I can. I will ask to Mr. Harvin. Yeah, by email. Yeah. Yeah, by email. So many in
Okay,
this.
thank you.
Thank you. You're welcome. Also, the last, Mr. Pil, yeah, and Mr. regarding JTech,
Antoine. Okay.
Anton, yeah. There is too many concrete in Indonesia to keep the temperature must be below 70, yeah, must be below 70 degree of Celsius. So they want to know about monitoring of the temperature concrete for mass concrete, yeah, for so many mass concrete for the building, for the toll road, yeah, something like that. Also for the smelter. And regarding the use of cement, maybe you can in here. I think not cement, but cementitious. Yeah, cementitious. It mean cement plus fly ash, cement plus apa slag. Yeah. So we can reduce cost again for cementitious. Yeah, not only cement. Yeah. This is for the JTech. Yeah, and for the Mr. Pill. Yeah, for roaster. Yeah. This is also in line with the 3 million hosts for people, yeah, for people at Indonesia. So the question is the equipment and width of width of the modular. As you know, in Indonesia, only 2.4 and the height maybe 2.9 or to 3 meter, yeah, maximum. And the width of the modular, I think must be considered with the crane, yeah. How much crane that we will need, yeah. As I see in your video, maybe around 50 or yeah, something, I don't know. I think this is my question, yeah, for the speaker. Thank you. Terima kasih Bu
Yeah,
Dewi.
thank you
Jadi
Pak
nanti
Dudung. So for
yang Hardwin saya akan detailkan pertanyaannya. Yang kedua dan ketiga saya sudah sampaikan tadi. Yeah.
Siap. Oke, izin Pak, mungkin nanti berikutnya kita bisa coba explore kembali untuk mungkin seperti meeting one to one gitu session ya Pak dengan
Oke.
beberapa member yang tertarik gitu ya Pak. Oke. Thank you Pak Dudung. Thank you so much for sharing your insight, input, and feedback from previous presentation. I think from the field side, I mean, like from the Lotus Star, I think they will also provide training, right? Phil, correct me if I'm wrong. So it's not about only, having partnership, but they also will provide training, and then we also support how many cranes that will be need. Of course, they will provide that information as well. Depends on the project size, right? Yeah. Phil, you
Yeah,
want to
correct.
jump in?
And the modules do come in different size options as well. So we could ensure that the product that's introduced is the best fit for that market.
Okay.
Yeah. And then previously I talked about Dudung, so in local language. So I think it's good to explore further. So we can also from now we can also arrange like a setup a one-to-one meeting virtual online with some of the member of AP3I to explore further. Yeah. So I think conscious of time, we need also to close the session, the Q&A session, and then we move forward to the closing session. And because the time is really challenging right now. I know it's already late in the evening in Canada. And then again, thank you so much for all participants, all the speakers. We would like to express our sincere thanks to AP3I, to Ibu Elvi as the chairman, Bapak Dudung as Secretary General, Ibu Liz and team, and Embassy of Canada as well, particularly Bapak Francis Despati and team, and all of our speakers, Hartwind, Hashui, Antoine, and also Phil. Thank you so much for being here, and also all the partners, participants for your time and contribution. Just a few reminders to the participants. First, all participants will receive a certificate which can be collected within 1 week. Please follow AP3I Instagram for further updates. And then second, the presentation materials will be shared after the webinar. So ensure you have confirmed your attendance by completing QR code. And then AP3I will also publish the presentation material to their website. And then the last but not least is about we welcome Indonesian companies interested in exploring potential collaboration with Canadian companies, including Earthtech, Jettech, Factor Corrosion, and Lodestar. So feel free to connect directly with them, with the speakers, contact our embassy team as well. An in-person event also planned for July 28 to 30 this year in Jakarta, offering an opportunity to meet them in person as well, face to face. And then we also welcome to set up an online call, one-to-one meeting to explore further, because conscious of time, each of company can just deliver 15 or 20 minutes, but feel free to have further discussion more in details, more on technical things. So I encourage you to contact them directly, reach out them, and then don't be shy. And again, on behalf of AP3I and Embassy of Canada, I would like to thank you once again to you joining the webinar. We do hope that today's discussion will be valuable and insightful for you. So I look forward to connecting with you in the future events, and have a great day ahead. Thank you so much, everyone.
Thank you, everyone.
Thank you, everyone. Mr.
Thank you,
Harbin,
everyone.
Bye bye. Have a
Mr.
good day.
Phil, yeah, Mr. Anton,
Thank
and
you.
Yeah, thanks, Dodo, and
Mr.
thanks,
Hausi. Yes.
yeah,
Thank you. Bye. Have a great
Bye.
day.
See you
yeah.
later. Bye-bye.
Good evening.
Bye-bye.
Enjoy the rest of the day.
Good
Have a
Good
nice
evening.
evening.
day.
See you. See you
Terima
Good
next
kasih Bu
month.
evening. Bye.
Dewi. Terima kasih Bu
Terima
Lis,
kasih Pak
Mas
Dudung,
Ade. Ya.
Mas Ade. Terima kasih banyak.
Thank you, everybody.
Terima kasih Pak Gunawan. Thank you.
Sama-sama, Dudung. Sukses.
Sama-sama, J.